Okay, welcome to stand-up meeting for January 21st, 2020. Today we're talking about graphs. It was the holiday weekend, so the students had Monday off, but they still had to cover graphs 1, and today we're covering graphs module 2. So I'm going to cover twice as much in half the time, and today we're going to see how the students did with their understanding of breadth first search and traversal and depth first search and traversal. Let's get the team in here. Oh, people might be confused. I posted the wrong link. Sorry about that, team. There we go. There's Catherine. Luis, Tani, and Obeda. Cool. Here we go. Here we go. Okay. How we doing? How we doing? Right. Okay. J. Cutting out my props. Not like React props, but like real physical props. So that you guys can see this really cool analogy I have planned for you today. You might find it really dumb or you might find it really helpful. Anyways, it's supposed to help you visualize things the way I did because I failed the graph sprint three times in one day. And I managed to also miss my 5-year anniversary dinner because I wanted to attempt the sprint twice more. So lesson learned. Angry wife, angry life. So don't make that same mistake. Don't do it. All right, I'll just oh, sorry about that. Let me disconnect this here. Okay. All right, let's get Jade up in here and we can get rolling. All right, so let's go ahead and get started. Let's go breakthroughs, 60 seconds. Start with Mr. Bryant Patton.
Okay, breakthroughs. I would say, I guess just, I feel like I have a better understanding of trees and tree traversal, even better than we first studied it. And I feel like I spent some time, bit of time re-going over that, like in depth, I guess. And so that's kind of my breakthrough. Other than that, yeah, I'm still going on today. I feel like I'm pretty close, but yeah, that's my breakthrough. So just
right.
popcorn
Yeah.
to Catherine because she's not muted.
Breakthrough, I was thinking about the problem one way and I was like banging my head on the wall to figure it out this way, and then I messaged my friend who I pair with, and so we're kind of like the inverse in thinking, and so she was like, oh well, I did it this way, and I was like, oh well, that works. Yeah, so
You're like, I'll go with what works.
I'll go with what works until I can figure out how to make my other way work. Yeah. popcorn, a beta.
Yeah. I got stuck a little because I think I had a hard time as well, kind of envisioning how it should look. And I mean, I did get it to work, but I just saw code right now that would have made my life a lot easier if I'd set it up the numbers way different. So shout out to Tanya and Jade. But yeah, so I kind of realized that the way I did it really complicated things, and if I had done it, I just didn't think outside. I mean, I just didn't think outside the box. I think that was like the biggest thing, which kind of limited what the solution looked like. It made it a lot longer than it probably should have or needed to be. Yeah, I popcorn glue.
I solved it. Breakthroughs mostly, I got through it a couple of times without it actually working. And I had to go back to my pseudocode and like adjust and just do it over and over again until it made sense somehow. And yeah, who did not go yet? Tani?
Well, I'm still going on it. But Obeda pointed out something which I guess should have been obvious. Jade and I were rewriting, I guess, the DFS function rather than just calling the function and using it. So that was that was a good catch. Thanks, Obeda. I don't know why we actually didn't make that connection, but yeah, but otherwise we're still going. So, Jade.
Sorry I'm late, first of all. Second of all, yeah, same thing with Tani. Breakthrough would be probably realizing how to use the data set part of this. And the Tico's help, like figuring out that was part of the issue why it wasn't working instead of hard coding in answers. So yeah, I'm with Tani. We're still working through the rest of it. Yeah, did everybody go?
Yeah, I believe that's everybody. Okay. So does anybody feel like they have a really, really good grasp of, I guess, let's just start with like a breadth first traversal or like a depth first traversal, and can explain it for the recording for anybody who will watch this in the future, for ourselves in the future when we forget breadth first traversal and you want to come back to it. Can you explain it in a way to your future self that you will understand it? And if so, go ahead. Anybody? Anybody? Can I raise, am I allowed to raise my hand? All right, so I've told the camera many times, I failed this sprint 3 times. I missed my 5-year anniversary dinner for the extra attempts I took on the sprint. That was so stupid. I'm gonna tell my future self, that was really stupid. Don't do that ever again. Okay, so I'm gonna start with a nice visualization of, let's go with breadth first traversal. So breadth first traversal, can somebody tell me what breadth first traversal is? Anybody?
Going level by level.
Level by level.
Neighbor by neighbor. So it's like 1 neighbor away from the starting, then 2 away. Yeah.
What else can you tell me about traversal?
Traversal goes across, it's going to reach every node if it can.
Correct. So what does it return in the end of that traversal?
A list.
Yes. And then can somebody tell me the difference between search and traversal?
Search returns. Oh, go ahead, Jade.
Search just returns it keeps going until we find the actual node we're looking for. Or traversal is actually going to go through the whole, the list or all the nodes.
Correct. Okay. So y'all might think this is remedial, but it's okay because I needed to teach to myself in this way in order to understand and to help my flex candidates who were in graphs flexing with me, and help them understand too, and it really helped them. So, so in looking at the steps for breadth first traversal, what's the first step you see?
Where you're talking about off of the graph class?
Yeah, actually,
function?
let me share my screen really quick here. So then the recording can see it too. So this is actually the solution, but oh well. You guys see my screen?
Yep.
Okay, so we're just looking at breadth first traversal right here. What's the first step in breadth first traversal?
Creating a queue.
Okay, and why do we want to use a queue instead of a stack?
Because of the order it pulls the nodes out of.
What is the next step in breadth first traversal after you create a queue?
You add in the starting point.
Yes. And then after that? Anybody help a brother out?
So we're creating a set, an empty set, in which we're going to keep track of every node or vertex that we have encountered in order to make sure we're not repeating ourselves.
Nice. Okay, good.
Or rather to make sure we visit everything.
Yeah, good. And then what's the while loop for?
It's to check while the size of the queue is larger than 0. So if there's something in there, you're going to do some things.
Right, so you're gonna keep going until that baby's just empty, right?
Yeah.
Okay. And then what's happening like on line 69 there? Anybody?
Popping off the first item in the queue.
Bryant, what is happening in the next block of code? Line 70.
It is saying if the node is not visited, then like do your function like print it, or add it to a list, whatever you're doing, and then add it to visited. In this case, set the set of visited, and then it it loops through the rest of the nodes. Like it finds the
line 73.
Yeah, it finds the neighboring, I guess the next left node, I guess.
You're right. Yep, the neighbors, all the neighbors. And then what does it do with those neighbors?
Adds them to the queue.
Nice. Okay, so I just wanted to demonstrate visually because I'm a super visual person, and in being super, I have my boy Super Mario brother right there, number 1. Okay, so we got Super Mario numero uno right here.
Could you stop sharing Ticos so we can see your
I'm sorry.
whiteboard?
Yeah, I'm sorry. I forgot about that.
No, it's okay.
My bads. All right, can you guys see now? Okay,
Yes.
so we got it's me, Mario. Super Mario right there. Okay, so that way you guys will remember this. Okay, so sorry. So here's the scenario. We got Mario right here. Okay, you got his boy Luigi right here. Is that his brother? Is it like a brother like the way like, you know, like friends use it, or is like the way like brother like a blood brother? I don't know. They don't really have the same voice. Okay, so that's Mario. That's Luigi, and then we have this guy. I don't actually know his name. I think it's Toad. It's just Toad, right? What a weird name. Toad.
Toadstool? Or no?
Toadstool. Is it
Toadstool.
Toadstool? It's Toadstool.
thought-
Okay. And then she's Princess Toadstool.
Peach, isn't that? Princess
Peach. I'm sorry. Peach.
Yeah.
I see. I mean, all I needed was the
You just need to
illustration.
play
That's
more
all I needed.
Mario, that's all.
I just know that he says, "It's me, Mario." Okay, so we have these 4 individuals here, okay? And I've drawn for you here this beautiful drawing here. This is a building, okay? This is a building, and let's say that Princess Peach, right? She gets abducted by Koopa. Is his name Koopa? King Koopa? That's his name, right?
Yeah.
So anyways, she gets abducted, but we're gonna go through that with the in the search. So we'll just put her to the side here. But we're gonna use Mario to represent a stack, and we're gonna use Luigi to represent a queue, right? And then this gentleman here, Toad, he's gonna be your set or your visited. So let's just, right, and they're visited, and then Mario's your stack, and Luigi is your queue. Okay, so like the first part of the breadth first traversal, so that means we're gonna have to go through every single one of these rooms, right? And like Catherine said earlier, when you do traversal, you have to touch every room before you can go to the next level. It's all based on levels, right? And how fitting, because we're talking about Mario. Okay, so step 1, what's step 1? You gotta create a queue, right? So that's your boy right here, Luigi, okay? So he's entering the game right now. And his wingman is actually Toad, okay? And that's the next step, right? After we have to add the starting vertex ID. So let's say that Luigi is starting in room 101 to go and find Princess Peach, right? So then he calls his boy up, Toad, and he's like, "Yo, Toad, bro, add room 101 to the list of rooms I've already visited, so I don't do it again, all right?" And then Toad's like, "Yeah, sure, why not?" So then that is the set. So he's the set. He's keeping track of all the rooms so that Luigi doesn't have to repeat them. And as Luigi goes through here, right? He's gonna pop off that first room, and he's going to print it, but he's going to check to make sure that it isn't invisited, right? So he's gonna say, "Hey, Toad, have I been in room 101 before?" And he's gonna say, "No, I haven't yet." So then go ahead and check for the neighbors. So then here are all the neighbors: 102, 103, 104, 105. So he adds those. So he tells his bro, "Hey, yo, add those to the list." And now your queue has like 4 other rooms in it. And so you have to like go through all of those before Luigi can go to the next level. And until he goes to the next level and next level and next level. And so that's like traversal, right? Until he goes through all the different rooms. And then when we start doing search, that's when we'll put in Princess Peach. And you'll stop at the room that he finds her at. So like he'll move room by room, right? All the way till he gets, through all the rooms on one level. Then he'll go up a level, same thing, all the way through until he gets to Peach. When he gets to Peach, that's when he stops, because with search, we stop when we get to our target. So yeah, that was a really crappy analogy, but I hope that it helped you visualize things a little bit better, because it certainly helped me. So maybe I'm just more remedial than the rest of you, but I feel like I just jogged my own memory right there. Awesome.
Thought it was good. I appreciated it.
It
Yeah,
worked.
thank you.
Thanks.
Yeah.
It was fun.
You sound like you had a lot of fun. Glad you had so much fun.
Sorry, tired.
No, I know. I know. Cool. So I figured with the rest of the time, we could just debug people's code and make sure everybody finishes their stuff for today. So if anybody wants to share like where they're currently stuck, maybe us debugging or mod programming together will help people have their own light bulb moments, and then they can fix their code. Get some rest tonight. So anybody want to share?
Okay, I'm just going to offer since Tani and I are working together.
Okay.
So preview is basically we created the, using the data set, we created and instantiated the graph, which is where we basically stopped. And then we have the DFS in here. We actually hard-coded in here instead of using it from graph.py. So that's basically where we're at.
Can you go back up to
Yes.
the top of your file?
Yeah.
So ancestor in ancestors, then for vert invert, you can just, I don't know if this will simplify, but you could just do like for parent child in ancestors. And then you can do add vertex parent, add vertex child.
So you're saying that you can create two different variables on line 73?
Well, like on 72, you can change that whole line
Or
just to be like a tuple parent child. So for parent child in ancestors, because it's like,
oh, okay.
Yeah.
All right, because it's a pair of parent child.
A parent and a child, yeah.
Gotcha. So, okay, cool. Let me, actually, before I change things, let me just do this for parent. Would it be parent and child in ancestors? Is that
It
how
would
you?
be like as a tuple, parent child.
So parentheses,
parentheses,
parent, comma, child.
parent.
Yeah, parent, comma, child in ancestors.
Okay, gotcha. To simplify
That's
it
cool.
and less.
Yeah. I
Thank
came across
you.
that 'cause I was doing like for I in range length and like I at 0 and I at 1, and then I was getting an error for some sort of like integer thing, and then yeah, I came through that. So yeah.
Okay, so just do for parent, child, and ancestors, and then are you just then grabbing just the parent?
No, you're going to be adding. You need to add, in order to add edges, you need to have vertexes. So you need vertexes for the parent and the children. So you're going to just run ancestor tree.add vertex add parent, and then also another line ancestor tree.add vertex add to child. Yeah. So you're going to have that, you're going to run that code because you want to add the parent. And so in order to have like edges are just like connections between two vertices, right? So when you have this list of like possible vertices, like you're going to add all the vertices and then you want to establish the connections.
Yeah, that's what we're doing here with this for loop.
Wait, so can I share mine just really quickly to make sure that I'm what I have is correct? So you're saying this, oh, where is it? Am I sharing the right, is this the screen you're seeing?
Yeah,
that's right.
Yeah,
okay, so you're saying like this?
Yeah, and then you can just do add edge, and then you can just add, so for parent child in ancestors, add edge, and you're just gonna add
us to just take this line out essentially and put it up.
Well, you're gonna have it look similar for parent child and ancestors, right?
Oh, gotcha. Okay, so then we're replacing ancestor again with this down here.
Yeah, and then
you're just calling a different method, right? Instead of add vertex, you're using add edge.
The add edge here.
Yeah. Well, yeah. So the line 9 for parent child just is a way to like make it easier for you to read. You can change whatever 9 is. 15 can be what 9 is. If that makes sense.
Okay.
The way you have written that for loop.
Okay.
Wait, so the way that they had it written before, they had a for loop, and this is inside of a for loop.
Yeah.
So like, does Catherine's solution actually improve the runtime then of that situation? Because before it was, or when you create two variables like that, two iterators like that at one time, is it actually like compounding like two for loops? Does anybody know?
I don't know.
I'll look it up. Please continue.
Okay, do you want me to just share my screen again? Okay.
Yeah, thanks.
All right, so I'm just going to leave it as is, but thank you, Catherine. I will definitely change that and see how that works. So the next thing I was going to do was grab, let's see, what are we using depth first? I was grabbing this and adding it to my utils file so that it's in here. No, wrong thing. There we go. Because Obeda, you had mentioned instead of redoing like we did here, that we can just use, okay, that didn't tell you what. We can just call this function and then add it. Is that what you were saying earlier to Tani?
Yeah, you can call one of those functions between the DFS and BFS or BFT or BFS. Sorry, yeah, BFS or DFS.
Okay, we were using DFS for our version. Then my question would be to you, what are we entering in?
I was thinking starting node and destination vertex.
What is our destination vertex that we're entering in then?
I think that was the issue that Catherine was running into
Yeah.
as well, right?
Yeah. So I initially I had gotten a late start because we like worked through like lunch, the afternoon breakout room, and then I was like, I need to eat real food. And then I thought about then I had a meeting with Tico, and so we had this way, and then I figured out how to set it up so I could make my adjacency list where I'd have all my vertexes, and then there'll be empty sets for anything that like doesn't have a parent. But then I was like, wait a second, but for a search, you need a starting node and an end node. Otherwise, like I'd have to like rewrite the code somehow. And I was like, I don't know how. I was like banging my head against the wall. I was like, I don't know how to do that right now. What's going on? But actually, if you just add the sets to have the children in your sets, like parent, and then the children in the sets, like your V2s is the children, then what you can actually do is you can loop through your ancestors array, like for parent child, and your parent can be a starting node, or it can be the starting node, and then that start node that you're passing in is like the end node. So you're actually starting from the top, potential top, and then like just returning like those lists, and then just checking the length of the list. So you're bringing in your DFS. I mean, I can share my screen if you want.
If you don't mind, or if Tico doesn't mind.
Yeah, go ahead.
So you're adding your edge, and then you're setting up this new path, right? And so then you're like, okay, well, you need in a search, you need like a start and an end point. So like initially I was like, okay, well, I'll start at that like child and try to go up the tree. But then I was like, well, this isn't working with whatever, because I don't know where I'm going to end up. But I know where I can start is like a parent, and then to see what kind of children they have. So you're starting at all your parents, and then you're doing your paths, and then you're just like seeing what's the longest path to get to 6.
You can actually also just do for I in graph.vertices. So you don't actually have to go back to ancestors.
Say it again, Obeda?
So you don't have to split up parent and child. If you do for I in well, I called mine graph equals big graph. I'm not sure
Uh-huh.
what it's called here, but dot vertices, it gives you like your 1, 3, 2, 6, 5, gives you all the numbers, so you don't have to split them up into parent and child.
So you just plugged in vertices as a.
Well, sorry.
Oh.
Yeah, this cough is refusing to leave. So if you do, I mean, this is how it worked for me. I'm not sure how. I'm pretty sure it should work for everyone like that. I'm not sure. Maybe if you want to print, Catherine. But like if you do like for I in your whatever you called your graph vertices, it comes back and it gives you each. Essentially, I would assume it's each key. So you'd get that 1, 3, 2, 6, and that way you can just go through the whole thing in one go for whatever's inside your graph.
Okay.
Mm-hmm. So where are we going from here?
No, everything else I had right. I was just saying that instead of splitting up into the pair key, it was just doing for I in graph dot vertices. I mean, because I called my graph that. You wouldn't have to go back and use what's being plugged in, rather just whatever's you've already sent over to your graph.
Then would you be iterating over an object though, right? Versus
Yeah,
like a list or like a.
versus an array of
Yeah. Okay.
tuples.
I got you. So it would return the keys then, huh? Each individual key, be iterating through. All right, Jade and Tanya, you guys still need to share your screen so we can get this, or? Still got like 12 minutes.
Let me just ask Obed if this is what he was talking about.
Sure.
So you were saying, I kind of did an example, or because vertices is already cleared here.
Mhm.
This is what I ended up, let me grab, actually.
So if you just print I instead of, so what you did right now is you're printing out the sets. So if you look right now, it says 10, 1, 2, set, 3,
Yeah.
5, 4. If you
So
just
you
print
just
out the I, yeah.
Because that would be referring to the values, right, for each key value pair in the
okay.
object.
All right. So it's printing out, there's 1, 3, okay. So that prints out all of those. Vertices, print I.
Okay. And then what was the logic behind, or the objective for doing that? What were we trying to get to?
Well, we know we need to get to what the end value is. We need to get to 10. But this would, I guess my question.
You just need I. If you do this with Obeda's way, you're still passing an I and the starting node into the depth first search.
Okay. So you're using each iterated over key as the starting value or the starting node, and then you are essentially traversing through the tree until you hit the value that you're originally passing into earliest ancestor for starting node, right?
Yes.
Because I represents like each individual node, aka vertex in the graph, and then basically you're just like you're changing up your start point every time. You're like starting from each one of those vertices, and then you're going all the way to the start point. But I mean, in this graph, we're moving downwards when we actually want to go like upwards, but it doesn't matter which way you go because you're technically just measuring the length, right? You want to find like the longest. You want to find the oldest ancestor, earliest ancestor. So that'd be the longest length. Okay. I see.
I think the way they set theirs up, they can actually do starting node comma I, just because it looks like the way theirs is going bottom up.
Ours is going, yeah, ours is going
Oh,
bottom up.
yeah.
That's the way we set ours up.
So if you were to actually print this out,
Print out what we're
yeah,
doing here.
yeah.
This up a little bit. So it's giving us the path which we have here. We just need to print out this last node.
Well, it's giving you all the paths for
Mhm.
whichever path includes
From 6 to 3.
starting node to I, yeah.
Yeah, it's giving us that path.
And you ultimately want which path?
The longest one.
Yeah. So how would you store the longest one as you're going through?
It would be the last one in the path. So we could call it like path -1, something -1.
So is it always going to be the last one? So like
It's supposed to be the last one because it needs to be the furthest from the child. One of the conditionals, it's the last one, but then we have to also decide whether we have to give back the smallest if there's 2. Am I misunderstanding?
well, because 6, for example, has 3 last ones, right? You can go to 4, you can go to 2, and you can go to 10.
Oh, okay. I see what you're saying.
So the biggest differentiator would be, first off, if it's, like you said in the beginning, if it's the longest one. And the second one is what you were just saying, right? The comparisons.
Uh-huh.
So how do you measure which path is the longest? What's the best way of measuring that?
I guess how many in your ancestry in this here. I guess which one is like if we were just comparing these 3, you'd have to get this path and see which one is your longest. So
yeah, go ahead.
like path.length.
Yeah, so finding the length of the array. if it has the longest length, then it is the longest.
Okay.
And so I think I was talking about this to Catherine, but another possible solution, I guess you could do is instead of keeping track of each individual path, could you also use like a counter so that you don't have to actually, I mean, I guess DFS automatically, it does that, but yeah, I was gonna say you could use a counter like variable that would just measure the length, the longest length, and just keep track of that. And then you're constantly comparing different lengths to that longest length. And if it iterates, if any of them are greater, then you would just make that one the longest length.
So you're saying like this longest length would equal, just instead of making it equal to like the array or whatever, you make it equal to the length of whatever the longest array was.
Mm-hmm. Because you're iterating through.
Yeah, that makes sense.
Right. But then you would need that longest length variable outside of you need it outside of that for loop, right? But I mean, I'm just throwing some crazy ideas out there. You do exactly what Obeda was saying because he knows what he's talking about.
No, what you're saying is right. I mean, that's what, yeah, makes sense. So I guess what are the variables you want to take account for? So you want longest length, and what else do you want to take into account? What do you want to return? What's the goal?
We need to return the node that's at the end of this array.
Yeah, and so we know that I represents the node, right?
Mm-hmm.
So then on top of the for loop, what else? So what are the two things you want to take into account?
We need to take in account the length and then just the I guess the last node
Yeah.
that's in this array.
Yeah.
So we can just do last node, or do, since I equals the node, would you want to do it inside the for loop?
Well, I don't know. You tell me. Where's the best place to keep it? I guess to call it in the beginning to keep store of the variable.
You mean so it
Where
doesn't
won't-
reset every time?
Yes. Yeah. So it won't reset.
It would be outside, because if you're doing it
Yeah.
inside, you're gonna reset it every time.
Yeah.
Okay. And then for the last node, I guess I'm still a little confused, because we know I is going to be the actual node. So could we just keep this empty as 0, and then we're like passing it by reference, or?
So what would be the point of last node, right?
Last node is to store the.
Exactly. Yeah. So it doesn't really matter what you put in here, or does it matter in the beginning?
It doesn't really matter, because we're going to eventually store it by going through this for loop.
Yeah. I mean, for now, yeah.
Wait, does Python, it's fine if you do this, or you have to equal it to something?
I think you have to.
Just
Yeah.
do that for right now. Okay. So if we were to do this here.
All right, so let me just get this straight real quick here.
Let me
Okay,
stop
so
sharing.
oh yeah, real quick. Thank you. So what we have suggested, or what we're doing now, is we're iterating through all of the through the nodes, and then we're keeping this consistent, right? So like if we're passing 6 in as our starting value, that's like our destination then for our DFS. Is that right, Catherine, or in Obeda? Is that so? Then you're passing in like you're passing in each of these becomes I over time, right? Because you're iterating through all of these. So all these become I, and then what you're doing is like you're traversing all the way down to this, which continues to be the destination. And then basically you're gonna like measure like the length of this. So this would be like 1, 2, 3, 4. All right, so I'm gonna add over here, the longest is 4 right now, for now. And then, okay, you go to the next one, this one. So you're gonna go 1, 2, 3. Okay, I stop right there. So that's not longer than 4. So I'm gonna go ahead and just skip, go to the next one. Is that the game plan there? Yay.
But
Yeah.
essentially the reverse for Jade and I.
Oh yeah.
It's the
From
the reverse.
bottom up. Yeah, going from
Well,
bottom up.
you're missing one more thing. You want to take into account the node that's giving you the longest. So in your drawing right now, you only have 4 equals longest, but you don't have which node is giving you the longest.
Right. Yeah. So I should have stored that as longest, or.
Well, I mean, you want to
Should've
store
stored that.
both technically.
Okay. Oh yeah. The longest, like the length of that.
Like longest path and furthest
yeah.
ancestor or something.
Yeah. Yeah. You're gonna
That's how I did.
store,
I'm not sure, Catherine. I'm not sure if you did any different, or Lou, or Brian, or whoever else finished. I'd be interested to see if someone had done it differently.
Yeah. Okay. That makes sense. Nice. Go ahead, Jade.
I actually have to get going. I have to
All right,
fix
no
dinner.
problem. No problem. Is it
So-
broken, or? Just kidding. That's a bad joke. Sorry.
No
Sorry.
problem.
Sorry.
I will be back later for anybody though. Tanya, if you're still working on this later.
Yeah, I mean, I can also share mine since we have
Go ahead.
very
Tanya.
similar.
See you guys.
See you, Jade. Anybody else that needs to go is free to go too. Thank you for everybody's help. Really appreciate it. See you, Luis.
Bye, guys.
See you, Catherine.
Bye. Yeah,
All right.
so who's still here? Oh, you
Let's
mean
do it.
Obeda.
I'm still
All
here.
right.
I'm still here. If Obeda has to go, that's
agree.
okay. I'm still here.
Well,
I have to leave for another 10 minutes, so I should
Okay.
be there.
oh, good.
Cool.
So let's. Okay.
So we got keeping track of longest path. We got furthest ancestor. Okay, so we're iterating through. Okay, so then I is changing. The destination is was changing.
So,
Yes, because we're going upwards. We want to go up. Okay.
so you're saying path.length. I guess a better way, I didn't do it like this, but
Yeah, it's
kind of what
JavaScript.
Ti-
Yeah.
yeah, but kind of what Tico was
Length of
saying
path.
though. Well, I mean, right now there's what is path? There's no path, is there? I don't know where your path is.
No, I got rid of it. So yeah.
Yeah. So I guess what Tico was saying earlier it's probably a lot better because you're storing an integer rather than an array. As if you could probably put that as probably a 0, right? And
Or
then
you can start as like 1 or something because it has to be at least 1, right? Yeah.
Yeah. And then what would you do with this longest path? You only need to store what in that variable?
You need to store the. I mean, like the number of.
You got it.
Integers in the path. Is that what you mean?
Exactly. Yeah, you're right. So the length of the array, the numbers in the array. So as long as it's just going to be
Okay.
integer, it's better than storing the actual array. It takes up less data.
So more like.
That's a good idea.
So kind of like a counter variable, like instead of actually keeping track of each individual like length, because then it would be an array of arrays that you'd be keeping track of, right? Or actually, no, you'd be keeping track of just an array of the different nodes that you're passing through. Okay.
And so what is this function now that you have inside the for loop return?
What is this function
Return.
here?
Yeah, what does DFS return?
Yeah.
So it's gonna. It'll give us like whatever we're starting with, as well as the last one, the last node.
So
or
yeah,
like
right.
the current node, I guess. But yeah.
So it takes those in, but what does it return back then?
Oh, it's gonna give us a list.
Nice.
Perfect. So what can we do with this list? What's the goal? So once we get back this list, what do we want to check?
The length of it.
Exactly. Yep. Compared to what?
The longest. Well, no.
Yep. Yep.
Oh, we do?
Yep.
So if. Actually, what are we calling this? Length of.
So you could do is line 26. You could set it equal to like a variable, line 26, and then that way you can just
sense.
measure the length each time of that. So.
Okay, so let's call it.
There you go.
Actually, oh yeah, I guess if it's equal to the longest path, then we want to return.
Well, like how do you want to compare it?
We want the last number.
Well, you're always going to be comparing to the longest path, but what do you want to do? How do you want to compare it? Like, do you want less than, greater than, equal to?
If it's greater than, you'd want to. If your list is greater than the longest path, that means that you want to update it. So, like that is your longest path.
Mm-hmm.
But what do you want to update? Your greatest time was right. That's correct.
Yeah, you're right.
But I mean afterwards, right? So like, okay, this is true. What are the things that need to be updated?
So you want to keep track of how many. You want to keep track of like the furthest, like how many ancestors are in this. as well as like our path length.
Exactly. Yep. So you're storing the length that you have right now, right? This new length that's longer than this new integer that's represents a length of the list that's returned is now greater than your longest path. And so what you want to do then is you want to redefine your longest path to be this new length. So that's right. And then you also, like you said, you're just trying to return that node. So we know what the node is here because what does printing I give us?
The current node. So in this
Exactly.
case, the longest.
Exactly. Yeah. So in this case, it would be longest, and that could be stored in which variable?
Furthest ancestor.
Exactly. Yep.
Right. So then I'm just setting longest path equal to length of. So like if
Yep.
this is greater, then I set these two equal.
Yep.
So like. And then.
There you go.
Yep.
Update it. Update it.
Now watch if you leave the for loop and you print I right now, what do you think you'll get? I mean, sorry, not I.
For this ancestor?
For this ancestor. I apologize.
Outside of this?
Yeah, outside the for loop.
I mean, shouldn't it just be 0 outside of it? Because we haven't.
Well,
or you mean like after, once we've run the for loop?
Yeah.
It should give you.
Oh, so he wants you to print furthest ancestor, not I, right there in line 31. There you go.
Sorry.
Yeah. There you go.
I don't know.
If you were to run it.
None type has no. Let's see.
Oh, okay. That's a good point. Okay. So, I guess something important to take into consideration is your node, for example. Let's say you're starting off with your starting node that they're sending down is 1, right? But is 1 connected to 6?
Yes.
That was a really bad example. But is 1 connected to 4? Sorry.
Oh, sorry. No.
Yeah. And so then that's going to return back a false. So, or a none, right? So length of none, you can't, there's no, it doesn't work.
Okay.
So then what's the solution? How do we fix that?
I think they wanted us to do -1. Or wait.
No, you're right. So later on they do want us to return -1, but as it's going through the for loop, as it's looping through all the vertices, it's gonna give us numbers that also are not connected to each other, right? And so how do we handle instances where it's gonna, because the whole idea of this DFS is gonna return back an array, but if it's returning, like if you were to print this right now, do you remember right there? You are printing. See, it says right there, ancestor DFS, and then it says 8, 9. Then it says none on the left. You see how it says none?
Yeah.
That's the problem. So how do we handle that? What's a good way of kind of maneuvering around the nuns?
Can I just skip them?
Yeah. So how would you skip them?
I mean, you could say if none pass, or you could.
Yeah. You could. That's one way of doing it. No, you're right. So it could be like an if else, right? So if this is none, then you pass, else do what you just did right now, right? Well, I mean, the whole point
outside of the for.
Well, is it outside of the for loop? Because where's the error coming? If you look back, where does the error pop? And then it says type error is.
So it's actually in the loop.
Exactly. So we'd want to do it before this error pops up, right?
Okay.
Well, I mean, ideally.
Actually, let's here. So if none, or no, if length is none, or I guess if,
So think about what you set your, so you called the DFS function on ancestor tree, right? And then you set it equal to that variable line 26.
mhm.
So that's what you're using every single time inside of your if else blocks. So use that same thing because you're comparing it right now. You're using the length of it to compare it to the longest path, but you can still use just DFS list.
So you mean like if DFS list equals none? Or could we just do the length of DFS list equals none?
Well, I mean, so the error is saying, what's the error saying again?
None type has no length.
So then would it run or would it not run if you tried to do?
The length of none.
It would not run because there's
Exactly, yep.
it has
So then
no
what's a,
type.
yeah.
Okay, so if DFS list equals none,
Mm-hmm.
pass.
Yeah. I guess a better way, I mean, I don't know if it's a better way, but I guess a question is maybe instead of doing that, wouldn't it be, wouldn't you, so you want to run your length DFS list if DFS list is true,
Oh, you're
right?
saying like put the condition in.
Before, yeah. So if you're saying like, exactly, so if you take out is none, and then maybe you tab the second if statement, what does that do? My question is, so if you keep it like this, what is that first if statement saying?
If there is a list,
Exactly, yeah. And so then if you're saying if there's a list, then
do this.
yep, exactly.
Okay.
Nice.
And then else pass.
Yeah. You actually with Python, I think you don't even need to do that. It just doesn't do anything, and then it'll just keep going through the for loop.
Oh, gotcha. Because it's
Yeah.
okay. That makes sense.
So now if you were to run it, let's see if it prints out. For this ancestor is 9. What are we testing on again? Oh, 8. Is that right?
No.
Well, because okay, maybe try flipping the starting node in I. Yeah.
Four. There we go.
Boom.
What are you printing out that's printing out earliest ancestor none? That coming from?
It's here.
Oh, down there. Okay. All right.
So it's
earliest ancestor. But then it's printing out.
so it's still not right
4.
then.
No, 8 is 4. I'm pretty
Is it?
sure. I can double check. So one second. Let me look at the tests.
Oh, because this is keeping track of the length, right? So this is just keep like how many ancestors.
Yeah,
and then the
it
last
is 4. Yeah. But now there's a few other things that you have to take into consideration. So like this is like at least when I was doing it, once I hit this point, I was able to pass the first one, and you should be able to. So if you were to comment out the rest of the test and then run it, so if you
this one.
So so, I mean, if you go to test answers.
Because this is giving me none. Okay.
If you go to this one, you comment out, if you comment out those, it should work. And then after that, this is where the other rules all come into play, where you have to like mess around with the. Oh, why did it fail? Why did you get
none? Not equals 10.
Because what's the problem with the code right now?
Where's the error at? Line 17?
Yeah. Saying none does not equal 10. So we still don't have a case for if it's.
Well, so at the end of the function, what's going on?
I'm just printing.
Yeah.
Instead of returning.
Yep. Yeah.
Okay.
Boom.
Nice.
Gotcha.
Maybe you should
And
change the
then
name of furthest ancestor to earliest ancestor. Might
Yeah, apparently.
might make it a little more.
I also have to hop off now. Sorry, folks. But I will be on later tonight. So, but I'm pretty sure you'll probably get it before then.
Nice. Good work, guys. Really good work.
Good work. Good time.
Yeah.
Thank you, Beta.
Good leading there.
No,
Good leading and
problem.
good following. That's good. That's awesome. All
I'll see you.
right,
See you
Obeda.
tomorrow.
See you, man.
Bye. Bye.
See ya. Good
Wait,
work,
I think
Tani.
furthest makes more sense to me.
Yeah, I think like it's more explicit. Like it's furthest from the the
Yeah,
starting node you're putting in. Yeah.
because otherwise
and
it's from. I'm gonna be a little confused
yeah, you can put that.
about what
I'm just
earliest
trying
means.
I'm just thinking of like the actual actual function. But you can do whatever you want.
Okay.
Yeah. So we want to change line 37 to furthest ancestor.
Oh,
You probably want
just
to change.
Wow.
You probably want to change the name of the function to furthest ancestor as well. So that, because somebody might look at it and be like, furthest, does that mean earliest, or is, that's where people will get confused.
All right. Well, let's go back to.
Whatever you want to do, though. I'm trying to prevent any confusion later on too when you come back to this like a year later for sure or something.
Wait, why can't I?
Huh?
I see what you're saying. So I'm gonna.
Yeah, I'm trying to
go back.
like foolproof your code for yourself. It's what I always do for myself because I go back and read stuff I wrote and I'm like, wait, what? So nice. Just make sure you're returning at the end of that function, right?
Oh yeah, I undid it. Okay. Let me double check that. Okay.
Nice. Cool. Good work. I will upload this video then for anybody who would want to watch this later. Cool. Good work.
Thank you.
See ya tomorrow.
Okay. Bye.
Bye.